Hello everyone, welcome back. Okay, so in this episode we are going to get into a little bit more of an advanced topic here. So I said in the very beginning of this series that this whole series is not entirely for beginners. And I did emphasize that I keep beginners in mind as we go through this whole thing. So that way everyone can keep up no matter what your level is. And everyone can learn and everyone can just have a good time and not get lost in all the code. But that said, this episode in particular is going to take a more advanced turn. We're going to be looking at making a variable store. And what a variable store will do for us is it will allow the user to define their own variables and their values within the dialog files themselves. And this is something that you'll see commonly within different visual novel engines, like RenPy, for example. You can create your own variables and assign them values. And we're basically going to be doing the same thing here. So when you're making your dialog files, especially in something like RenPy, what you can do is you can normally define a variable that you can store some data into, such as values that might change throughout the course of your story based off of what the player does. You want to keep track of it and be able to recall it at a later point in time. You can do this by setting commands to change the actual values of something in a script or a data container like we do with the dialogue lines, or you can define it within variables that can be saved directly within a save file once we get into that. So how this works is, as you code your dialogue files, maybe for your particular story or for a certain scene, you need to keep track of some information. That information can be stored in a variable, which is not directly defined outside in the external scripts, but is defined, created, and maintained within the actual dialogue files, and it just uses a store to cache that value and the data. That store could be saved into a file that you could reload once you resume a game session that maybe you stopped prematurely, and you would still have those values, and you can reference them, change them, and even use them for conditions directly inside of your dialog file. So as an example, if we were to define something like, let's say we were making a variable called money, then we could say money equals 50, okay? So we would have a variable called money equal 50. Now to identify a variable, we're going to use a little symbol at the very beginning of the variable name, which is the $sign. How fitting for money, huh? So the variable identifier is going to be the $sign, and the variable name will be what comes after it. And then we can have an assignment operator, which in this case is equals, and we are setting the value of this new variable money to 50. Now, if we were to do this without implementing a variable store, what we would need to do is we would have to create a command or something like set money, and then say something like 50. And then this command would reach into another script and set a predefined, pre-configured variable inside of another external code or external script to the value of 50. Whereas if we define a variable, we're not accessing any other external scripts. We're not accessing other classes. We're just accessing a variable store, and we're storing it in there, and anything can access it. And more importantly, our dialog files can access, change it, and just work with it. So this means we could even then come down and say money, and we could alter it by saying plus equals 15. Okay, simple enough, but how's that really useful? It can be useful as we get into a new logical line where we work with conditions. So the last video, we looked at making branching stories by loading different dialog files. So if we want to create any kind of branch in our story, we have to load a new dialog file. Well, with variables, we can bypass that. We can load a new dialog file when it's going to be big, long changes and like a lot of stuff that's just worthy of being put in its own file. But if it's small stuff, then variables can take care of that for us. So we could implement a logical line which just checks a condition. And a condition could be our variables. So we would start with if, in if, just like we're writing an actual script, if money is greater than 50, then we would execute some kind of lines. And that will only happen if our variable satisfies the condition. Another example of how this could be really useful depends on what type of visual novel it is you're making. So if you're making something like a romance novel where you can have different things happen based off of your relationship with the different characters, then you could define variables to keep track of, say, your affinity with these different characters. So you could use a different variable for Valerie's affinity and Susan's, and then compare the two, and then execute something if what that condition is true for. So if Valerie's affinity is greater than your affinity with Susan, then you can execute certain events and things that would happen in that case, and vice versa. So this really opens up the possibility for logic inside of our dialog files. So here's how this is going to work. I've got a diagram here. So we'll be creating a variable store, and that variable store is just going to be the access point to a database. And the database is going to hold all of the variables that we define within our dialog system. And speaking of those variables, there are two different kinds of variables that we can have. The first type of variable is an internal variable. And an internal variable is one that is created and stored directly within the database, and it's just maintained inside of this variable store. Anything can access it, but it has to go through the variable store and through the database to get to the variable. So through that database, you can set and you can retrieve that internal variable, but it has no references in any external scripts unless they are explicitly provided. This would be like our money variable, which is defined inside of the dialog file. Anything that we define and create within our dialog files or manually create within the database is going to be an internal variable. On the other hand, the other kind of variable that we can have is an external variable, and this is also called a linked variable. And this one does a little fancy magic. So what the external variable does is it's not hosted inside of the database. The only thing the database has is a reference of this external variable. What's really going on is the external variable has a connection to the actual variable in another class that is separate from the variable store. So by changing the external variable within the database, you are actually changing a variable contained within a different class. And that can be pretty powerful. But for our visual novel, the main kind of variable that we'll be working with is internal variables, although external variables will be possible as well. So let's hop into Unity, and the variable store is going to be related to our logical lines, so that's where I'm going to place the script. I'm going to place it right in here, and we're going to make a new C# script called the variable store. We'll want three namespaces for this. We want the system namespace, we want the system collections, and of course, Unity Engine. We only need Unity Engine because we're going to want to use debug eventually at some point. But we can remove mono behavior because it's not going to be attached to any object in the scene. And we can also remove start and update as those no longer apply. Now, to make this more user-friendly for us, we can have different sets of databases for different kinds of variables. So our first database is just going to be our default database, and anything that is not explicitly defined is just going to be placed within the default database. But just like we did for our commands, where we could have a character name and then call a command directly off of it, such as stella.move, we can do the same thing for our variables and define the name of the database followed by a dot to indicate that we were accessing a variable inside the database, and then define the name of the variable. So instead of Valerie_infinity, which would be stored in the default database, we could say Valerie.affinity and Susan.affinity. That way they could have their own databases and their own variables associated to them. And then it makes it more clear and more organized what variable belongs to what. And so our variable store can have the default database, and then it can also have a list of additional databases that we could define and create for ourselves, depending on what we want to be able to access and reference. This will not have any impact on how the variables are retrieved or even what kind of variables are stored, but it's simply for organization and structuring things in a way that is clear what belongs to what. You can think of it like folders on your computer. So now that we've got all the explanation out of the way, let's go ahead and get coding now. We got started a little late in this video coding because there's a lot that needs to be understood, but I hope that we have laid the groundwork and that everyone's clear on what we're doing right now. So we have our variable store, and we now need to create the class which will be for our databases. This class is going to be a public class called a database. And the database is just going to consist of one item, which is going to be a store of variables. And I'm just placing it inside of this database class within its own container to organize it and give it something that that we can access the variables through. So we can clone this dictionary just by cloning a database. So exactly what we're creating in here is going to be a dictionary, and we'll be able to look up a variable by a string, which would be its name. So there's our title, and now we need something to actually store the variables in. Now, one thing to keep in mind is what kind of variables we'll be making. We're going to keep it simple, and we're just going to do an integer, a float, a boolean, and a string. And if you want, you can add more on top of that later. But these are the ones that we're sticking with. We're just going to keep it fairly simple. But that still gives us 4 different kinds of variables. So let's make a class for our variable type that any object can be a part of, and we can give it some functions that we can do to set and retrieve the value, which would be especially useful for our external linked variables. So let's go ahead and make a public abstract class for our variable. We want to abstract because we're going to make each variable of a different kind, and it's just going to inherit from this base class, which will tell it certain things that it can do. And the things that we want to be able to do with any variable, no matter what kind of type it is we want to be able to get a value and we want to be able to set a value. So let's do public abstract void called get, so we can retrieve the value of this variable, and public abstract void set, so we can set the value. But we need to provide a value, so that's going to be an object type, and we'll just call it value. Okay, and there's our base variable class. So we can go ahead and say that our dictionary is going to have the name for a variable, and it's going to have a variable type. And this dictionary will just be called our variables. So each database is going to have a list of variables that it can work with. So now let's actually create the generic subclass for our variable type. So public class variable, and we need to specify the generic type t, since this can be of any type, but it's going to inherit from our variable abstract class. Now, first thing we'll want to do is we'll want to implement the abstract class, so we get our getter and we get our setter. Now, as far as how we're going to do this, since we can have both internal variables, which should just reference a value that is local to the variable store, our variables will be able to store a value in here. So we'll make a private, because only the variable needs to know it, we'll just access this value through the getter and the setter, and we'll call it value. So this is the actual value that would be tied to an internal variable. It will be stored in here, and we can access it through the getter and the setter. But if it's an external variable, then, and actually even if it is an internal variable, we still need to make a way for it to retrieve it. So let's go ahead and make a private variable for these two things, and it's just going to be a reference to the actions that are going to be performed for whether we get and whether we set something to this variable. So function with the generic type t is going to be our getter. And the reason we're using function here is because function returns a value. And we need to return whatever we are retrieving, which will be this value. Now, for setting, we don't need to return a value, so we can just use action, which will not return a value. Specify the generic type and just call it set. So now we can store get and set and define what they're going to do. Okay, so let's make a way to construct this variable from scratch. So public variable, we make our constructor, and let's go ahead and define a couple things in here. Let's define whenever we create a variable, we can pass in a default value. So we can, if we're creating an integer, we can pass in 15. If we're passing in a string or creating a string variable, we can pass in what it's going to start out as. So it needs to be the generic type, and we'll just call it the default value. And by default, it's going to be equal to the default of whatever this type is that we are creating. And let's also make it where we can pass in a specific getter and setter if we so choose. That way we can link it to an external variable, because the only way for us to link this variable to something in a different class, to a variable in a different class, is either through commands or through a getter and a setter. And that's what these are going to do. So if we create a variable that uses a getter and references another variable, then that's how we can pass it through to this internal variable store. Okay. So function t, this is going to be our getter, and that's going to equal null because we won't have to pass it in by default. If we don't pass it in, it's going to generate it by itself, and it's going to point directly to the internal value. If we do pass it in, we need to manually point it to the external value. And now let's go ahead and make the action for the setter. So of type t, and setter equals null. Okay, now as we have our default value, let's go ahead and say that the value of this variable equals the default value. And now let's evaluate if this is an internal or a linked variable. We know it's a linked variable if our function getter and setter are not null, because we have manually created a link. So if get equals null, then we need to create a new setter. So we will say set equals some new kind of operation. And this is going to be a lambda expression, which all it's going to do is reference our internal, not get, not set rather, that needs to be get. So if get is null, then get is going to equal a new lambda expression which just returns the internal value of this variable. Otherwise, get should equal the getter, whatever we've passed in, and that will provide a link in this variable to an external variable. So let's do the same thing for setter. So if set equals null, actually I'm getting my variable names wrong. If getter equals null, then we create a new get function. I may just go ahead and rename these just so I know what I'm doing. Okay, so if the parameter getter is null, then this getter becomes a new value. Otherwise, this dot getter equals the link. And if setter equals null, then this dot setter equals some sort of operation. We need to take in a value, which I will call new value, and we're going to point that to a short little action that's just going to say our internal value equals the new value that we're passing in. Otherwise, this dot setter equals the link. Okay, there we go. So if we receive a request to create a new integer and we determine that it's not linked, then it's going to create a new default variable with that value stored inside of it locally. However, if we do have a link, as identified by receiving a custom getter and setter, then we'll create a new variable which will not have an internal value, but it will have a link towards the actual value that has been linked within that other class. And that's just what's going on here. So as for getter and setter, we can remove the default implementations, and if we call get, let's just call the getter function. And if we call set, which takes in the object new value, then we're just going to point that equal to our setter and say that type t is our new value. So we're going to provide a new value of this type, whatever is assigned to our variable. Okay, so we have our variables and we have our database. Now we just need to go ahead and create a database. So let's make a public. I want everything to be static. I don't want to have an instance to the or reference to the variable store inside of the scene. I want anything to be able to access it at any time from any place. So I want everything to be static. So let's make a static Boolean return to tell us whether we created this and it succeeded or if there was an issue. So we'll call it create database. And this is just how we'll create a new database by a certain name. Now, the only way this is going to return false and we actually won't create the database is if one already exists. In order for us to know that, we need to have a list of databases, or actually, more accurately, a dictionary of databases. So I'm going to come underneath the variable here and just make ourselves, we're going to have a private static dictionary, and this is going to contain a string for the name of the database as well as the database type. And this will have all of our databases inside this variable store, including our default database. But to make it simple, let's go ahead and make a reference to that default database so we can access it pretty quickly. So private static, and this will be a database called the default database. And this is just going to reference our databases, and it's going to grab a database called default, which I'm going to turn that into a constant up here. So private static, private constant string default database name. Okay, so when we get the default database, we'll go ahead and grab it using the default database name. Okay, so now when we go to create the database, let's make sure it doesn't already exist. So if not databases.contains key by the name that we're trying to add it, then we'll create it. And we'll do so saying databases by this name equals a new database. And we'll go ahead and return true. Otherwise, if we already contain it, let's return false because we did not create the database. Now that we can create one, let's try to get the database. So if we try to retrieve a variable from a particular database, we can go ahead and do that. So public static database, and we'll call this get database, passing in a string for the name. And let's go ahead and just make sure that the name is not empty or null. So if name equals string.empty, then we will return the default database. Otherwise, if not databases.contains key, the name we're looking for, if we don't have a database by that name, well, then here comes the choice where we can either create one or return nothing. In this case, I think I'm just going to go ahead and create one. So I will choose to create a database by that given name, and then just return the database of that name. So this will allow us to create our databases. Now, let's go ahead and do something real quick and just make a way for us to see what databases are inside of our variable store. So let's make a testing script real quick. That way we can interact with our variable store. I've just created a new script called variable store testing and placed it inside of the Unity scene. Here you can see it in the inspector, and it is the only script active. In order for us to print out all the databases, just to see what we've got, I've made a static function called printAllDatabases, which goes through each pair inside of the databases and just prints the database and its name identified as the key. So inside of the testing script, if I say variable store.printAllDatabases, we should see all the databases that are created. But in order for us to really see that working, let's go ahead and create some. So variable store. Let's go ahead and create a database, and I'm going to make a database 1 and 2 and 3. So we'll go 54. I don't know why. I just chose it. And then if we hop into Unity, we can see, yep, we have database DB1, DB2, and DB54. But our default database is not in there because it hasn't been created. We need to make sure that it is automatically created for us. So to make that happen automatically without having to call any sort of initialization functions, since this is not going to have any instance inside of the scene, and we don't want to manually do that ourselves, we just want it to happen automatically, then let's come right down to our databases and just make sure that when we initialize it here, then let's go ahead and populate it with a default value. Now, inside of the brackets, since this is a dictionary, we need to make more brackets. So that way we have the pair for our string and our database. Now the name of the database is going to be the default database name, and it's just going to be a new database. And then without changing anything else, now when we print our databases, we can see that default is listed in there among the others. Perfect. So we know that our databases are populating, and now we can go ahead and start assigning variables to them. So I'm going to minimize these other two functions, and I'm going to keep that in case I want to use it later. Might be good to have in the class anyway. But now let's go ahead and create a variable. So the same way that we'll create an internal variable is the same way we'll create a linked variable. They'll both run through the same function, which will be a public static Boolean called create variable. I'm making it a Boolean, that way I can know if it succeeded or not. Now we need to pass in a generic type here, which will be identified by the default value that we provide inside of the parameters. So to create a variable, we need a string for the name, that way it can be identified. We need the type with a default value, and then let's just go ahead and say that we're going to define our getter and setter to be optional here. So we can have the func t getter, which equals null right off the bat, and action t setter, which is null as well. And with these two being null, this will by default create an internal variable. So here's how we're going to do this. We know that our variables can be associated to different databases, so we need to see if there is a database identifier or a database symbol in here that tells us if this particular variable we're creating is part of one other than the default database. So let's create a string array to split the database from the variable name if it's present, and we'll just call it parts and say it is name.split followed by that dot. But you know me, I'm going to take that dot and I'm going to move it to a private constant character and call it the database variable relational ID. I'm sure I could simplify that, but I can't think of a better name right now. So we're going to split it by that relational ID. And now we want to go ahead and try to get our database. So database db equals get database. And this is just going to be the first item. So we will have parts 0. The first one will always be the name of the database. Now let's get our variable name. So string variable name, which should be created in that database, is going to be different depending on if we actually split this string or not. So let's see if parts.length is greater than 1. If it is, then we want parts1. Otherwise, we want parts0. Which means if we split it, we're going to get the second item. Otherwise, we're going to get the first and only. Okay, now let's check if the database already contains that key. So if db.variables.contains key, and we want to look for the variable name. If we've already got this variable, let's return false, and we don't need to create it. Otherwise, db dot variables, and we'll pass in the variable name, equals a new variable. And we're going to make it of the specific type that we're creating. We're going to give it a default value, as well as a getter and setter, potentially. And then we will return true. And based off the constructor logic that we defined for our variable, it will go ahead and take care of linking the variable for us. We've just got all the values and we are ready to go. So we've now created a variable. Okay, so as far as accessing the variable, we want to be able to both retrieve the value that is assigned to that variable as well as assign it directly from our variable store. So let's start with trying to get the value. We'll make this public static and we'll have bool for whether it succeeds or not. So try get value. And we're just going to pass in a string for the name. And we need to cast out the value in case it succeeds. So out, since we don't know what kind it is, it's just going to be an object, and we'll call it variable. Okay, So we'll do the same thing that we did for our create variable up here, where we split it to see if we have a database and get the variable name. So maybe what I'll do is I will extract that into a separate function, and we'll get all the information that we need there. So let's do that. Let's make private, and we will return a tuple. What were those values again? I had a string array, so a string array for the parts, and string array, and then a database, and then a string for the variable name. And we're just going to call this extract info, taking in a single string for the information. Okay, so I'll go ahead and paste that in here, and instead of, let me just call that name. Okay, so extract info, and we are going to return a new tuple with our parts, with the database, and with the variable name. Okay, so when we create a variable, let's go ahead and do that. So let's say string array parts, then database db, and string variable name equals extract. Did I make that? I did not. Let's make that static. So private static. So that is going to equal extract info, and we're going to extract it from our name that we have passed in. Okay, so let's just copy that line, and we'll paste it in try get value. And when we try to get the value, let's again see if our database contains the key. So if not db.variables.contains key, our variable name. If it doesn't contain our variable name, then we need to say that variable equals null and return false. Otherwise, our variable is going to equal the database variables, but we need to call get on that. That way we can retrieve it. That's not value. It's supposed to be variable. And I'm getting an error here. It says cannot convert type void to object. I think I gave get the wrong, I sure did. Get needs to be a object return. So let me make sure I'm doing the same thing in here. Get needs to return an object. It can't be void because we are expecting a return. So let's come back down here. Okay, so our variable is going to equal whatever is currently assigned to that variable. When we grab the variable from the database, that's just the variable container itself, and get will either return the internal value associated to that variable or the linked value inside of whatever variable that it is pointing to. And then we can say return true. Okay, we try to get the value and we can successfully do that. Now, as for setting the value, let's make a new function for that. So public static, and this will be another boolean, and we'll call it try set value. Again, we'll take in a string for the name, and then we need a generic type. But if we're going to specify generic type, then we need to make sure that this function is marked as generic. So t value, and now we can go ahead and grab those parts again. We'll grab them here, and then let's go ahead and grab this line as well. So if our database does not contain the key, then we will just return false and we're not going to do anything. Otherwise, we're going to go ahead and say that variable, or not variable, db.variables, and then we're going to grab it by the variable name, and just call the set function that is assigned to it and apply the value. Then we will return true. By doing it this way, we can both get and set internal and external variables. So before we go any further, we're basically done here. but let's go ahead and test it and make sure that we can do just that. Actually, beforehand, since we can print all the databases, how about we go ahead and print all the variables inside of a database as well? As a slight modification, I went ahead and made a constructor for the database where we can pass in a name that gets assigned to that database. And we just store the name alongside of the variables, which means when we go ahead and initialize it and we create the new default database, we just pass in that default database name as we create the new database. Simple enough. And when we create the database, we need to do the same thing. We go ahead and assign a new database by that name to a new database and making sure that it knows that its name is what we are passing in. That way, in addition to print all databases, where we can print every single database we have, we can also print all variables, where we can pass in a specific database and choose to print all the database variables on that database. Or if we don't specify one, we'll go through every database and print all the variables in every database. And what that function does is it just goes through all the variables inside of our database, and then it prints out the database name as well as the variable that is associated to it. So when we go ahead and create the databases, let's go ahead and do something. I'm going to go ahead and make a void for update where I can do some key presses and see and make some changes to the variables that we're about to create. So in database 1, we're going to create a couple variables there. These are going to be internal variables. So we will go ahead and say that variable store dot create, not a database, but create a variable. And we need to pass in a name for this variable. So this is going to be var1. Or this is going to be num1, actually. And num1 is just going to have a default value of 1. We're not going to pass in a getter or a setter. So we're essentially creating an internal variable called number1, which has a default value of 1. And I'll go ahead and make num5, which will have 5. And let's also make a boolean. So let's make light is on and set that to true. So we have created a boolean. The other thing we can do is we can create a float. Whoops, I accidentally pasted my other print function again. So we'll go ahead and make a float, and we'll call this float 1, and that's going to be 7.5. Other thing we can do is we can make a string. So variable store dot create variable, and we'll make a string called str1, and it'll have a value of hello. One more, string 2, you know where I'm going with this. Hello world. Okay. So after we print all the databases, I'm also going to say variable store.print all variables. And I'm not going to specify any database in particular because I want to look at all of them. And what I see is a slight issue. So we have our databases which are printed out, and then I can see where I also have database num5. It's treating all my variables like databases. So when I created these variables, it actually went through and decided to create a database instead of a variable. So let's take a look at what's going on there. This is when we're getting our database. So we need to look at the extract info function. And database db equals get database parts 0. Ah, yes. So that should only be the case if we have indeed split something from our parts, because then we have a database specified. Otherwise, it needs to be the default database. So let's look and see if parts.length is greater than 1. If it is, then we get the database by that name. Otherwise, we should get the default database. And if we run that again, we can see we only have default db1, db2, and db54. Those are the databases. And all my variables, you can see, got assigned to the default database. And we have all those variables with their names and their values, which are stored inside of the variable store. Now, if I want to divvy this up, and let's say that database numbers is going to have our num1 and all that. So I'm going to say database numbers.num1 and database numbers.num5. So we should create the database like that, and how about database for booleans? So we'll do that for our light is on, and also for our db others. So I'll just stick those in default. So we know what's going on. But I will go ahead and place the float inside of db numbers. And if we run that back in Unity again, we can see default, and we have our new databases right in here. We see default database has the strings in it, the numbers database has the numbers, and the Boolean database has the Boolean. And just to make things a little easier to read, I went ahead and reformatted these functions so that way we can see clearly the name of the database and the variables listed out in a line. So they're not all in different lines. So it makes it easier to read. We can see the variable name and the value that is currently set to, which will be great for our testing here in just a second. In case you're wondering, this is what I changed in print all databases. We are just logging it with a different color. And in print all database variables, I've changed this up slightly to use actually completely, to use a string builder, and then we're just appending the lines, and at the very end, we go ahead and log that one single line. That way, everything is in the same log statement, and we don't have to go through multiple logs. And of course, they have their own colors, and since rich text is enabled in the Unity console, we can see those colors applied. Okay, so in update, whenever I press the Q key, it's going to print all the variables, and I can see if anything has changed. Now, let's go ahead and try to change some of these numbers. And I've implemented two other key presses here, so if I press the A key, then I'm going to find number 1, and I'm just going to get the value, and then I'm going to set the value as what it currently is, plus 5, making sure to cast it from an object to an integer, since that is the type that I'm loading. And if I press the S key, then I'm going to get the value of number 1 and number 2, and then log a statement showing me what number 1 plus number 2 is. If we're able to set the value of number 1 through the variable store, then we should see a different output each time I go to log this. And if that's the case, then we will know that our variable assignment is working. Let me make sure I got the right number in there. I did not do number 2, I did number 5. And yeah, there we are, number 1 and number 5. That's what we're looking for. Okay, so as we start, if I look at the database, I can see that number 5 is number 5, and number 1, this is the one that I'll be working with, is number 1. So if I go ahead and press S, then num1 plus num2 equals 6. That's correct, because 1 plus 5 is 6. So now let's go ahead and tap A, and let me go ahead and hit Q, and the database should have updated. Yep, number 1 equals 6. Let me press A 2 more times to increase it by 10, and Q once more. Oh, whoops, hang on. AA, and then Q. Oh, here we are. Yeah, so let me take collapse off. Okay, there we are. DB numbers, variable number 1 is now 26. So if I press S, then we can see num1 plus num2 equals 31. So yeah, we've got internal variables that are working and they are updatable. A again, Q, and yep, 31. Okay, our internal variables are working. And two more key presses here to test the other variables. So we've got our Boolean and we've got our string. So if I press the D key, then I'm going to toggle light is on. And if I press the F key, then I'm going to append world to hello, so I should get hello world. Okay, so here we are. Default database has hello world, so let me go ahead and do F real quick, and then we'll queue it. And let's see, default database now has hello world. So our string concatenation worked for that variable. Let's look at the numbers. If I go ahead and say A, let's increase A, and then we can already see the debug message works down there. Let's Q, and we see the number is now 21. Okay, how about the Boolean? The light is on right now is true. Let's press the D key, Q to refresh, and light is on is false. D again, Q refresh, light is on is true. Okay, our internal variables are working. So how about our linked variables if we wanted to do that? Okay, so I've defined a couple variables up here. These are public and we should be able to see them in our inspector. And if we look in Unity, we can indeed see those variables are listed and are on this variable store testing script. So any changes we make should apply directly to these if we make them linked, and we should be able to see them update in real time in the inspector. As for creating those linked variables, let's go ahead and do that right now. I'm going to make a new variable store, or database rather. So variable store.create database. For some reason I can't type, as if I ever can. Create database, and we will make this db links. So we'll create a new link database. And what we're going to do is make some variables linked to these values up here. So let's start with the integer. So variable store dot create variable, and we're going to create one which is called lint. Okay, so that is my linked integer, and the value is going to default to whatever var int is right now. And as for our getter is going to equal a function. Now the beautiful thing about lambda expressions is we can define it right. We can define it right here. So I will make my expression for the getter, and that's going to return var int. And as for my setter, we're going to take a value which will be passed in to make our var int equal the value. That's our link for an integer. So down the bottom here, let me go ahead and make a new function or command thing, whatever you call it. Get key down, and we will say keycode.z. So z is going to update my integer. So I can go ahead and say, let's try to get the value first. If variable store.try get value, I want to get lint because that's my linked integer. I'm going to cast it out to an object type, and this will be, and I'm just going to call this linked integer. So if we get that value, well, I don't really need to use if there. I already know it exists, so I'm not really going to do a safeguard. I'm just going to try to get the value and then change it. So then variable store.try set value, and we're going to set the linked integer to, let's cast that to an int, what we just grabbed, linked integer plus 5. So we should see it increment by 5. So inside of Unity, let me go ahead and hit Z. Let's watch variable integer over here. As I hit Z, because it's linked to the variable store, it is updating the actual script's variable. So we can see that it's updating in our inspector, so it's actually affecting the variable in its memory space directly, which is really neat. And we can look in our default store, lint. Oh yeah, I didn't assign it to the links database, whatever. So inside of our default database store, our database, we can see that the integer is updating here as well as in the inspector, because what we're seeing in this database is actually just a reflection of what it's actually updating over here. Now, that is really neat in its own way that we can actually link up this variable store to the values here. So what that means is you could have a script with data that other scripts will access. And they don't have to reach into the variable store. They don't have to perform casts or anything like that. The variable store does it automatically, and it updates whatever they're accessing in real time. And it can continue to do so, but the thing that you must be aware of with lambda expressions is if we save and try to reload, we're going to have to reload the link as well, because the link will not be saved if we save it to a file. We need to make sure that if we have links set up, that there is something that will always reestablish those links whenever we stop and restart Unity. In this case, the link is constantly reestablished because I have it so inside of the start within variable store testing. So if you're going to use linked variables, make sure that you are aware of that. Otherwise, you will come up with some issues and some null reference exceptions, and that is because your links are dead. Okay, so that is working pretty well. So we're able to create our databases, and we're able to create variables as well as get and retrieve their values, whether they are internal or externally linked variables. So how about we go ahead and make a way to remove variables in case we want to destroy them from this variable store. So let's start by removing all the variables. Let's just go ahead and purge everything. So public static void remove all variables. Ain't no going back from this one. So databases.clear, we're going to clear all the databases, and then we're going to say databases, and we'll just recreate the default database equals a new database of that default database name. Okay, so that's how we can remove all variables and clear out our databases. So let's now focus on just removing one variable. So public static void remove variable, and we'll pass in a string for the name. And we're going to go ahead and grab this stuff. So same deal, we're grabbing the parts, the database, and the variable name by extracting the info from whatever name is being passed in. And let's just do a quick check. If db.variables.contains key, if it contains a key by that name, then db.variables.remove that variable. Just make sure that we use the variable name and not the whole name that we've passed in, because that's what's been extracted. Okay, so we should be able to remove variables and clear out our databases. Okay, so if I press the G key, I'm going to remove the linked integer as well as the boolean for whether the light is on. And if I hit the H key, then I'm going to remove all variables and all the databases. So right off the bat, we can see that db booleans has the variable light is on, and db links has the linked integer. Again, if I hit F, or what was it, G? Let's go ahead and Q. Then we can see my links is gone and my boolean is gone. They have been removed from the database, while all of the other ones are still in their place. And if I hit H, and then let's go ahead and hit Q again, database, default. We only have the default database left, but it is fully empty because we've cleared everything out. All right, so our linked integer is working. Now let's go ahead and just check out our float and our boolean and our string as well. So to create the links, let's duplicate this line and change int to FLT for the float. And the only thing we need to change is the variable reference here. So var float, float, and float. Everything else is the same. We can duplicate that twice and do the same thing for our boolean and for our string, or str. So I'll copy var bool, make var bool, paste, 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 and then copy var string, paste, paste, paste. And we now have a link to all of those variables. And if I press the X key, then I'm going to multiply the linked float by 1.75. If I press the C key, I'm going to toggle the linked boolean, and if I press the V key, I'm going to append a string with a random range from 1000 to 2000. Okay, so right off the bat, we can see that our db links now has the 4 linked variables in it. So if I go to press the Z key, I can see the integer incrementing. Let's press the X key, but I need to set the default of float to 3. I'm doing this manually, so let's actually refresh this again and look at our linked variables. Yep, you can see it is just picking it up straight from the inspector. So now let me go ahead and press X, and we should watch it multiply by 1.75. Ooh, specified cast is not valid. What is this error? And so apparently this is happening because I did not put an F at the end of 1.75, so it was actually being sent to this variable as a double and not a float. And I've also gone ahead and changed these to get key down instead of get key, just so that way they only trigger once when I press them. Okay, so Z increases integer, F increases float, C toggles the boolean, and V appends digits to the string. Perfect. If we just go ahead and refresh our database, dblinks has all the correct information. Now, on the surface, it doesn't appear to have such a huge benefit for us, but once we start working inside our dialog files and we're able to reference things just by a variable name, and we're able to use conditions and logical operators and expressions, it's going to be very useful for our dialog files and making them more dynamic and increasing the capabilities of what we can do with them. And we'll actually start working on that in the next video. For now, I've run out of time and I've got to cut this one off here. But we've got this variable system up and working, and that lays the perfect groundwork for the logical line that we're going to get into in the next video. So I'll see you guys then.